Hi, greetings. My name is Muzammir bin Azwan. Today I'm going to do a video presentation of my mini project assignment. But first of all, I would like to thank my tutor, Mr. Partiban, and my course coordinator, Dr. Mama Ezri, for the assistance in helping me completing this mini project assignment. As for my mini project assignment, I chose to solve mathematical problems of linear equation. My programs will solve the linear equations problem almost immediately, and at the same time, it will also plot the 3D graph once the answer is obtained from the equation, from the question input by the users. And as for now, I will show my coding line and the explanation behind each of the coding line. And, and finally, I will show the demonstration of the projects to you. Thank you. Hi, okay. Now I will explain the coding line of my program. As you can see here, I am using NumPy as my Python external module. This is due to NumPy is a general purpose array processing package, and it is the fundamental package for scientific computing with Python. Uh, Here, we use the import to tell Python to bring the NumPy library into our current environment for my program right here. And for the SNP, it will tell Pythons to give NumPy the alias of NP. This will allow us to simply type NP rather than NumPy for any function that we want after this. And the next one is Matplotlib. Matplotlib is a cross-platform data visualization and graphical plotting library for Python. And it is also a numerical extension for NumPy. It actually offers a variable open source alternative to MATLAB. Same as NumPy, import tells Python to bring the Matplotlib library into this current environment of our program. The SPLT will tell Python to give Matplotlib the alias of PLT. This will allow us to simply type PLT for any Matplotlib function after this, rather than we fully type matplotlib.pyplot, which will save us a lot of time actually. Meanwhile here, for graphing to this program, we need to bring some integral module into our program by enabling the toolkit, which is the coding line here. It will utilize the dimensional graphing in Matplotlib that is already built in here. Also, for here, for graphing color, this is why we need to use the coding line. It will allow us to access all the built-in color map in the Matplotlib. We can choose and we can find a good representation in 3D color space for our data set that we will obtain later when we run the program. Which at the same time it will also make it easier for us to view and differentiate the plotted line on the 3D graph with different color plotted on the graph. Okay. So this print function here, we will utilize it to print specified message to the screen once our program is executed. In this case, it will be a guidance on how the user need to convert their linear equation, before they input it into the program. It will specifically tells the user on how to enter their formula. Okay, the ABCD, EFGH, IJKL represent the each input of equation from users that input into our program. The map here will take two arguments. The first one is the method to apply, which is the float, and the second one is the data to apply to it, which is the input. It is used to typecasting every element on the list to an integer value. Meanwhile, for float, it converts a number stored in a string or integer into a floating point number or a number with a decimal point. This is important as float are useful for functions that need precision, like scientific notation. Meanwhile, the input await for the user to type something or input something into the program and return it as a string. In this case, the formula of linear equation input by the users. So here, split is utilized to create Python list out of the string. It will break the string by spaces. Okay. Now to solve a linear equation, we will use this formula right here. Um, The NP array, this here, NP array is a data type consisting of more than one element. This array can be used to solve constant value, such as here ABC, AFG, and TKR. And for BA, NP array, this will be used to solve the constant value of the equation. Meanwhile, for the NP.linear, it is used to solve the linear metric equation in our program. This is one of the most important one because we need to get this right to make sure we obtain the correct answer for our linear equation. Uh, and the solve function will calculate the exact x of the matrix equation, which is ax equal to b. Okay, so when we are working with numerical application using NumPy, we need to create an array of number. We need the number to be evenly spaced. But there are also times when we need non-evenly spaced number. So in this situation, we can use np dot linspace that has two required parameter, start and stop, that we can use to set the beginning and end of the range, which is 0 to 10 here for our program. And the purpose of the np.meshGrid, which is meshGrid, is to create a rectangular grid out of an array of x and y values. It returns two-dimensional array representing x and y coordinate of all the points. Okay, so here we will integrate the linear equation to each three input equation by the users. Okay, for PLT.figure, we utilize it to create a figure object for our 3D graph. So for this function, it is used to return the same object as axis 3D. This become possible when we import axis 3D from MPL toolkit. This is important for us to plot our 3D graph. Okay, so for AX plot surface, we utilize this to create 3D surface plots. Meanwhile, for alpha here, we use it to regulate the transparency of graph using the alpha attribute. The darker our transparency, if the higher it will be. For example, it can be 1.5, something like that. Okay. So for the color map, here we use the qualitative color map because we use Essence, Pad, and Pastel One. Um, they are used to present the info that does not have ordering of or relationship of our 3D graph. Okay, so here, okay, so here, this is defining the seed formatting like color, marker, and lifestyle. Yeah, it use line 2D properties as key argument for more control on the appearance of the 3D graph. And the AX set here is a function in access module of matplotlib library which is used to label all the axes on the 3D graph. And lastly, the penalty shows here to display all figures that we obtain from the equation, and this is displayed on the 3D graph. It's used to display all figure obtained from the equation and applied to the 3D graph. Okay, now I will show you the demonstration of my projects. Okay, now we will take a sample question and compare the answer. Okay, so this is the sample question. We will take the first equation 252 negative 38. Okay, and for equation 2, 3 3 negative 2 4 17. Okay, and for equation 3, negative 6 ones, negative 7, and negative 12. Okay, so as you can see here, we immediately obtain the answer, and the 3D graph are plotted here: x-axis, y-axis, and z-axis, and the different color for each of the axis. So now we will compare the answer. Is it the same? And the final answer is x3, y negative 8, z negative 2. Okay, so we have the same answer. So there you go. The linear equation interpreter and 3D graphic update. Thank you.